Right. Hello. Good evening, everyone. And if I'm coming through to you right, we can straight away start. Right? Yeah. So just give me a thumbs up so that we can go. This is tutorial number 13. Tutorial number 13. Tutorial number 13 and right. Okay, good. Tutorial number 13. We are in question number 8, part number C. Right? I think we couldn't discuss that part. Right? Question number 8, tutorial number 13, unit number 1, question number 8, page number 5, part C. Right? I hope everybody is in par with me. Right? Okay, so let's begin. The following table gives the successive ionization energy of an element in period 3. Successive ionization energy. So you get 786, the first one, 1580, second one, 3230, third one, 4360, that is the fourth one, and then you get 16,100. And you can clearly see that there is a very significant difference between the third ionization energy and the fourth ionization energy. I3E and I4E. This is the place where you have a big difference. So that means in the last energy level, how many electrons are there? All these 4 electrons are removed from the last energy level. So there are 4 electrons in the last energy level. How are the electrons filled? It is filled according to S2P2. So what is the group number? Can somebody tell me? Can somebody suggest the group number very quickly? Group number? Yes, exactly. Yes, very good. Group number? Yes. Yeah, yes. So it is how many electrons are there in the last energy level? Yes, there are 4 electrons. That means it belongs to group 14. So it belongs to group 14. If it belongs to group 14, what is the first thing that they are? Identify the element. Period 3, group 14. Look at the periodic table. Period 3, group 14 is silicon. The answer is silicon. Identify the element, right? Part D, it says, explain why the ionization energy of every element is endothermic. What is the reason? For all the elements, the ionization energy is endothermic. Because if you look at the atom, here there's a nucleus and there's an electron also. There's an electron as well. This is the electron negative charge. This is the positive charge, right? They are like kind of attracted to each other, right? The positive charges and negative charges, there's an attractive force. So when you're trying to remove this electron, you have to break that attractive force. That is why energy is always absolute, right? So shall we write down what is the answer that you write? So electrons are attracted to the nucleus, Therefore, energy should be supplied. Energy should be supplied. To break the bond. Break the force. And therefore, it's endothermic. Right? Right. Okay. Right. Good. Question number 9. Shall we work it out? Complete the electronic configuration of sodium ion, Na plus. What can you say? Sodium plus. First of all, let us look at sodium, right? So I will erase the plus charge here and I'll write sodium here. What is the electronic configuration? 1s2, 2s2, 2p6 and 3s1. So there's a very one electron at the outermost energy level. Sodium plus means you can have to remove that outermost electron. 1s2, 2s2, 2p6. Very easy now. Things are okay. Part B says, write an equation including the state symbol to represent the process for which the energy change is the second ionization energy of sodium. So what is the process for the second ionization energy? I'm like looking at your answers also, right? Good, good, very good. So what you have is you have sodium plus in the gaseous state and the outermost electron is removed. So you get sodium 2 plus in the gaseous state and one of those electrons are removed. One of those electrons are removed. Did you understand that? So that's what you get. Explain why the second ionization energy of sodium is greater than the second ionization energy of magnesium. So if you look at sodium plus, what is the electronic configuration? 1s2, 2s2, 2p6. We have already written that. Magnesium plus, what is the electronic configuration? 1s2, 2s2, 2p6 and 3s1. Now you are going to remove the second electron. When you are removing the second electron, for sodium, you have to break the octet. Octet needed to be broken. Octet needed to be broken. So if the octet needed to be broken, you need to supply more energy, right? So more energy is needed. But do you have to break the octet for so magnesium plus? No need. No such necessity. No such necessity. So therefore, sodium plus, you need more energy, isn't it? No, the sodium plus, you need more energy to break it. But then magnesium plus, you don't need that. So at least you need to say that breaking the inert gas configuration of sodium. That's okay. Na? I hope everybody understood that. Huh? There any question you need to ask, right? Everybody, I hope like that. Can I write breaking the inert gas configuration? Yes, of course, you can write that. Yeah, yeah, right. Good, good. But the third, right? Try the third one. It says an element X in the period 3 of the periodic table has the following successive ionization energies: 577, 1820, 2740, and then 11,600. Now the energy, high energy is in between the third one and the fourth one. That means there are 3 electrons at the outermost energy level. Electrons out. Outside you have 3 electrons. Outside 3 electrons means it gives you S2P1. It belongs to group 30. Same kind of thing. Everybody okay? Right. Is it clear? Right. Right. Okay. So then say deduce the identity of the element. Now it belongs to period 3. It belongs to period 3. Period 3, group 30. That is, you can look at the periodic table and it gives you aluminium. Aluminium. Aluminium is Al. Al is that. Right. Okay. Then part C, it says, state and explain the trend in atomic radius in the periodic table element from sodium to chlorine. What happens? Sodium to chlorine, what is the trend? Sodium to chlorine. Can you tell me what is the trend in radius? Radius, it will gradually decrease, isn't it? Radius decreases. Decreases. Or you can say sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. And you can say, you can draw it like that. This is the trend. So this is also one way to say that. Or you can say that the atomic radius decreases across the period. Right? Is it clear? Right. Okay, right, okay. And then what is the explanation? What is the reason? Explanation. 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 What is the explanation? What do you think? What happens? The number of energy levels doesn't change, but the effective nuclear charge increases because every time when you move from one element to the next element across the left hand, from the left hand side to the right hand side, you are adding one more proton to it. One more proton means effective nuclear charge increases. so that the electrons are attracted towards the nucleus. So therefore radius decreases. That's all you need to write. Okay? Is it clear? Yeah. Just looking at this one. Right. Okay. So you can say effective nuclear charge increases. Nuclear charge increases. So that is why. Right. Okay. Right. Effective nuclear charge increases. Right. That's what you have. 2p6 is only having 6 electrons. So how does it have to be broken? Doctor, 2p6 with a 2p6, S2p6. This is the second energy level. There are 8 electrons. Tama, කොහෙද හිටියේ මේ එච්චර කාලයක්? 2p6, 2s2, 2p6 that is the second energy level. We are looking at the entire energy level, right? Not anything else. Hari. Question number 10. Question number 10. How does it work? Right? Any other questions? Anything that you didn't understand? Right, Hari. Which one of the following is the correct electron arrangement of copper? Copper plus 2, copper, all these things are there. Right, I'll write the electronic configuration of copper. What is the copper electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. So 3d9 means 3d10 and 4s1. This is your electronic configuration. This part is what is called argon configuration. So you can say argon configuration 3D, 3D10 and 4S1. Argon configuration 3D10 and 4S1, right? Okay. So copper plus is not 3D9, 4S1. Because if you are removing one electron, copper plus gives you argon configuration 3D10. Copper gives you argon configuration 3D10 4S1. So that is also wrong. It says 4S2. Copper plus 2 configuration, you remove one electron from 4S1, you remove another electron from 3D. So that will give you argon configuration 3D9. That is also wrong, right? Then it says copper plus gives you, what is copper plus? Argon configuration 3D10. I think that is the best answer. Answer number D is the best answer. Would you agree with that? Right? Okay, right. So that was question number 10. Right. But the question number 11, how does it work? Tell me how this is going to work. Which one of the following lists the first ionization energies of elements in magnesium, aluminium, silicon, phosphorus, sulfur in the order? Right, okay. So let us see how this is going to work. Now, can you remember how the first ionization energy vary? You start with this, you say up, down. Then what is the next one? Up, up, down. And then up and up. Right? So that's how the variation take place. So this is group 1, this is group 2, this is 13, then this is 14. What is the next one? 15. This one is 16, this is 17, and this is 18. Right? So what are these elements? Magnesium, aluminium, silicon. Right. Let's start with that. It belongs to sodium. Right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. That is how the variation take place. Right. First one is magnesium, aluminium, silicon, phosphorus, sulfur. So if the magnesium is 577, this is 577, the other one is 786. That is what they have given. But actually it should go down. 786 means gone up. So A is not an answer. A is not an answer. So that's wrong. Right? So I'm going to erase this part. 577. Right. Next one. 736. If this is 736, they have given this as 577. That's okay. Na? It has gone down. 786. Okay. 1060 and then 1000. I think that is a good answer, right? B is the right answer. You can see second one you had to drop. If you look at C, 786, 1060, that is wrong. It can't go up. 1060, 1060, 1000, 1200, 1500, and you can't have 480. 480 is very significantly low, much lower than all of these things. I think C is also wrong. D is also wrong. So only right answer is B. Question number 11 is that. How about question number 12? I hope you got those answers, right? Ready? Over there. Right. Okay. Good, good. Well done. Very good. Yeah, well done. Okay. Okay. Well, very good. Very good. Very good. I'm just looking at those. Right. Oh, good. Let's see how the next answer comes in. Now, everybody should give me an answer to this. Which one of the following atoms has only two unpaired electrons in its ground state, lowest energy state? Right. Which one? Helium. Helium means 1s2. Now, no unpaired electrons. Beryllium. 1s2, 2s2. Again, no unpaired electrons. Nitrogen. 1s2, 2s2, 2p3. There are three electrons, three unpaired electrons. Oxygen, 1s2, 2s2, 2p4. 2p4 means if you have 3p orbitals, you have the first electron, second electron, third electron. There are 4 electrons. So this is the unpaired electrons, 2 unpaired electrons. Neon, it is definitely S2p6. S2p6 means 0 unpaired electron. So they ask you to give you 2 unpaired electrons. 2 unpaired electrons. D is the answer. Are everybody okay with that? All of you got those answers? Right. Yes, D is the answer. Very good. Oxygen. Well done. Right. Okay. Right. Let's see. I'm just looking at your answers. Right. Oh, very good. Right. Well done. Then question number 13 is the last question in that tutorial. Question number 13. In which of the following pairs is the first ionization energy of element Y is greater than the element X? So first ionization energy should be, Y should be somewhere here and X should be somewhere there. That is what you mean by that. Y is greater than the element X. Electronic configuration of X. 1s1. 1s1 is hydrogen. 1s2 means helium. I think that's the right answer. Eh? A is the right answer. I feel like A is the right answer. That's good answer. 1s2, 2s2. Beryllium, right? Beryllium and boron. Beryllium and boron, there is a drop. So cannot be that. Hey, why you remember how the thing work? Up, down, up, up, down, up, up. So this is beryllium and this is boron. So this can't, why don't have a higher value? Then next one is S2P3. That is nitrogen and oxygen. Nitrogen and oxygen is also, there is a drop. The C is also wrong. Neon and sodium. Neon is here. Sodium is the next one. There's a significant drop. D, that is also wrong. So only answer is A. Right. Okay. So that will bring us to the end of this one. Mother. In the 12th question, why have they asked about the ground state? Isn't it the first state? Ground state is not the first energy state. It is the minimum energy of the electron, minimum energy of the atom that you consider. All the electrons should be as lowest energy as possible. Not the first energy level. First energy level can have only 2 electrons, right? It can't excite. The electrons can be excited also. They are not excited, that's all. So it's a ground state is that. Question number 13, can you explain it again? Right, okay. So question number 13, it says, which one of the following pairs, first ionization energy of element Y, second element, has a higher value than X? If you look at hydrogen and helium, helium is breaking the octet, hydrogen is not breaking the octet. So therefore, A is the right answer. All the others, there is a drop in the energy level. Looking at the first energy level. Did you understand that? What do you mean by the third ionization energy? Third ionization energy means you are removing the third electron, right? A2 plus. If you remove another electron to give you A3 plus, that is called the third ionization energy. Oh, note it's given in the note. Okay. Right, now question tutorial number 13 is all done. Now, then tutes I did, right? Tutorial number 14. So let us look at tutorial number 14. Tutorial number 14. Let's work it out. Right? Tutorial 14. Let's see as much as we can do. Let's try to work it out. Right? So this contains some of the exam questions as well. Question number 14, there are some exam questions also I have included in some of these things. Question number 1, right? Tell me what you think about this. Now everybody should kind of pay attention, try to answer and then be ready, right? The element X with the atomic number Z, atomic number is some value, we don't know, has the general electronic configuration Ns2 Np4. Now, can you tell me to which block the element belongs to? Which block? Now, they don't ask. They don't ask that. Which block the element belongs to? It belongs to what block? Very good. P block. Because the last electron fills into a P sub energy level. P block. Can you tell me to which group it belongs to? To which group? Which group it belongs to? What is the group it belongs to? Group number 14, 16. Group number 16. Group 16. It belongs to group 16. Right. Okay. Now it says write the electronic configuration of the element where N is equal to 3 here. Right. Very good. So what do you do? 1s2 principal quantum number should be 3. 2s2, 2p6. Then you get 3s2, 3p4. Make sure to study every day. Because if you can understand the first unit, second unit, and the third unit, chemistry you can understand very easily. You have to kind of understand it really well. Read it, do some work, do some past paper questions, do these tutorial questions. If you can find some other questions, you do it. You have to write it down. You will become great at this. Write down the next one. What is the next answer? Type it. Write the most stable anion formed by X and write down the electronic configuration of the anion. So this is anion. It can take 2 electrons to complete the octet. Most stable anion is 2 minus. So if it is X, you can say X2 minus is the most stable anion. What is the configuration? You are taking 2 electrons, 1s2, 2s2, 2p6, 3s2, and then you take another 2 electrons, 3p6. Right? Okay? Right. Do that. Right. Oh, very good. Very good. Like the answers. Right? Try to, as much as possible, you try writing the answers also, because I'm sure you are great at typing. Hari mama දැකලා තියෙනවානේ අර පන්ති කරන වෙලාවෙ type කරනවා අපි we are doing the class and sometimes people are typing so hard මේක දඩ බඩ ගාලා කරන්න ඕනේ right වරද්දන්න බෑ right write down the electronic configuration of the element with the atomic number Z plus 3 right Z is group 16 යා කියන්නේ Z plus 3 that means how much what is the element this is what is the element? Can you tell me what is the element? The period 3, group 16. Period 3, group 16 means sulfur. Another 3 electrons, chlorine, argon. What is the next one? Chlorine, argon, potassium, I think. Right? Did you understand that? Another, yes, very good. Potassium. Z plus 3 is potassium. So what is the electronic configuration? 1s2, 2s2, 2p6. 3s2, 3p6. And then you need to add one more electron, 4s1. Did you understand that? 4s2 then. Borugan 3d1 really unknown. Right. Right. Good. Good. Right. Okay. Write down the electronic configuration. Write the formula of the compound Y forms with X. Right. This one will form K plus. This one will form X2 minus. Right. Let us say it says electronic configuration Y. Okay. Right. I will not say K plus. I will say Y plus. So how do you write the formula? By exchanging the valencies. Y2X. Y2X. Did you understand that? Very good. Very good. Well done. Right. Technical errors. Technical errors. And then can I join again? Oh, it will be uploaded to the website. Uploaded to the website. And then this is it. I mean, XY2 we don't write that. XY2 because we write the cation first. Cation first. Cation first, followed by the anion. Followed by the anion. Anion second. So it's the norm. IUPAC norm is that. Right? International norm is that. So you write it as Y2X. Did you understand? Is it wrong if you write K2S? No, it's not wrong. They haven't said write the proper chemical symbols. You think Y2X is the better answer. K2S is right, but Y2S is the better answer. They haven't said anything about that. So how did you determine Y? How did you determine Y? Z plus 3 Z plus 3 and Z in the first some place, Z is there in some place, you go 3 atomic numbers away. It's simple there. It's not you have a certain number at the 3. How do you know it says Z plus 3? Did you understand that? Y2 minus for the anion, Y2 minus for the anion, anything S2P4. S2P4 means you have S2 2 electrons. P4 means you have 4 electrons, 1, 2, 3, 4. In order to complete the octet, you have to get 2 electrons. It will accept 2 electrons. Valencies are that. Right. Okay. Everybody okay? Right. Good. Well done. Good. Draw the variation of the first 7 successive ionization energies of X. Now, X is this. X. This is X. So we are going to draw the first 7 successive ionization energies. So what I'm going to do is I will try to copy this thing. I don't know the format has changed. Yeah. This is the electronic configuration. This is the electronic configuration and we are going to remove these electrons gradually. So whenever you are removing electrons, you remove it from the outermost energy level. Right? Last to come, first to remove. Outermost energy level. So this is where you are removing electrons. First you remove 4 electrons from the p energy levels. 1, 2, 3 and 4. Right? After removing these 4 electrons, you have to remove another 2 electrons. Now they are removed from the s orbitals. So it's a slight change, s orbital, slight change. Now this is removed from the s orbital. Right. After removing those 6 electrons, you have to get the octet, inert gas configuration you have to remove. Now that requires a large amount of energy. So this is the next term. Right. So this is the first electron, this is the second electron, this is the third electron, this is the fourth electron. All of these electrons are removed from the p sub energy level. Then you are removing these 2 electrons from the s sub energy level. What is 3s? This is 3p. And then you are removing this from 2p level. That's all. Did you understand that? Is it clear? I don't understand how to guess the gap, but you can't guess the gap. You have to measure. But when you are moving from very high, like, one energy level to another energy level, there is a huge gap because those electrons are closer to the nucleus. Right? Those electrons are closer to the nucleus. Right. Okay. Aren't everybody okay with that? Right. Can't we put a straight path to 6 electrons? Take a berry because, these are slightly different. Like, they are not removing from the same energy levels, right? P and S are slightly different. So there's a slight change. But 3S and 2P there's a big difference. So there's a bigger change. Everybody okay with that? Right? Won't the last one be 2P5? 2P5 once you remove it. Yeah. It doesn't matter. So there are we are looking at the energy levels. So ionization energy, NIE. This is the electron removed. Once you remove the 7 electrons, it will be 2p5. Right? Before that, it is not 2p5. Once you remove it only, it becomes 2p5. Why the big gap is there while going to, again, why the big gap is there while going from 3s to 2p? 3s is in a outer energy level. 2p is in a inner energy level, closer to the nucleus. So it is attracted more. And when you are trying to remove that electron, you need to supply more energy. Did you understand that? Simple there. Right. Okay. Okay. Right. So this is good questions. Right. Good questions. Very good. Right. Okay. Question number 1 is okay. Right. Balan, the second question. What do you think about the second question? Do you have an answer to it? Explain what is meant by the covalent radius, van der Waals radius, and the metallic radius. The covalent radius, we talk about it. Whenever an atom forms a covalent bond with another atom, right? Atom forms a covalent bond with another atom. How do they form a covalent bond? By overlapping these bonds, right? And then what you do is you measure the internuclear distance. You measure the internuclear distance, D. So covalent radius is equal to that distance divided by 2. So if you put this into words, it is half the internuclear distance when 2 atoms form a covalent bond with each other. Right? Half the internuclear distance. Internuclear distance when 2 atoms form a covalent bond with each other. Right. So that's a covalent radius. Right? It's like, maybe it's better if you can look at the book also. We have written these things. That is why I'm going through this tutorial again, right? I'm going like little later, I'm going through this so that like, those who have studied it better, you can like, finally put the final nail on that knowledge, right? Van der Waal radius. Can you remember what is Van der Waal radius? Right? So they are not forming a covalent bond. Instead, what they do is these two atoms, right, they approach each other. When they approach each other, since they can't form a bond, there is a temporary distortion of the electron cloud. There is a deformation of the electron cloud. Temporarily, the electron cloud is deformed like this. The electron cloud is deformed like this. And this becomes delta minus. This becomes delta plus. The side where you have a greater electron density becomes delta minus. The other side becomes delta plus. Side where you have a greater electron density is delta minus. The other side is delta plus. So that is called a Van der Waal force. What is that called? Van der Waal force. It's a temporary force. Very weak interaction. Very weak interaction. At that time, if you look at the internuclear distance, you look at the internuclear distance, this d. So Van der Waal radius is equal to d divided by 2. Whenever two atoms are bounded to each other using a temporary Van der Waal force, if half the internuclear distance is taken, that is called the Van der Waal radius. Right? If there's any problem, you need to ask, huh? Right. Yeah. Any problem, you have to ask that. Right? Okay. Clear? Right. Then the next one is, third one is, what is the metallic radius? Metallic radius are found in metals. Now, we talked about metals. Metals contain cations immersed in a sea of electrons. Cations immersed in a sea of electrons. These electrons are mobile. They move here and there. They move here and there, and the cations are stationary. Right? So you have these electrons like this. They are like, moving here and there. You see, like that. These electrons are the ones that will hold them in place. Right? Like that. So these are called mobile electrons. These are called mobile electrons. And now what you do is you look at the half the internuclear distance. This atom, this ion, you take the measurement here and then take half the internuclear distance, half the value. That is called the metallic radius. So when atom, can I draw the diagrams too with the definitions? Of course, because chemistry is all about structure determines properties. Whatever the thing that you talk about, you talk about the structure. So structure is most important thing, right? Structure determines the properties, right? So make sure you accompany this with if they ask for a definition or something there, like explanation, make sure to accompany that with a diagram. Because, like when you were small, diagrams speak so many words, right? Diagrams speak so many words. Right? Clear? Okay. Good. Very good. Somebody asked me, Van der Waal, Van der Waals radius works only with pressurized helium. Van der Waal radius work with any compound as long as they come closer to each other. Right? They can come, if they can come closer to each other, it is that, right? So that is what you have. The clear definition is this. Clear definition is this: half the internuclear distance when an atom forms another, when atoms forms a metallic bond with another atom, or in a metallic C structure, the internuclear distance divided by half. So if you want to say what is the metallic radius, it is half the internuclear distance. I'll write it. Somebody said, please write it down. Half the internuclear distance, distance when atoms are bounded to each other in a metallic bond. In a metallic bond. Did you understand that? That was question number 2. Right. Okay. Any questions, Buddha? Anything that you need more explanation? Right. Why don't nuclei get close to each other in van der Waals radius? Nuclei don't get closer to each other because nuclei repel. Nuclei is positive charges. If they come close to each other, they repel. So here also the same thing. Electrons also repel. They are repulsions. Right? Okay. Right. Yang nilagata. Question number 3. Read the question. Explain the variation of the van der Waals radius from the left side to the right hand side of the periodic table, right? Left hand side to the right hand side of the periodic table. Anyway, whatever the radius that we talk about, what will happen? It will decrease, right? So if you look at these configurations, it decreases, right? Decreases from the left to the right. Left to the right. Why? Because of the increase in the effective nuclear charge. Due to the increase in the effective nuclear charge. Right? Make sure to read the note. Note is very elaborated. Okay, right? Sir, can metal sodium, magnesium have covalent radius? They can't have covalent radius because they don't form a covalent bond. If they are forming a covalent bond only, you get a covalent radius. Otherwise, you don't have a covalent radius. Right? Right. Okay. Can you? A lot of people ask, can you explain the van der Waals once again? The van der Waals කියලා කියන්නේ, this is a very simple thing. If you have an atom, no atom එකක් තියෙනවා. Right? We have to explain this. මේක අපි theory note එකේ දාලා ලියලා තියෙනවා. හරිද? So please read that. You have two atoms like this and you force them to come closer to each other. But they are not going to form a bond. Right? When they are not going to form a bond, what will happen is it gives you the electron cloud when they come closer to each other. We come closer to each other. And this is also closer to each other. So now what will happen is electron repulsion take place here. Electron repulsion is taking place. When the electron repulsion take place, the electron cloud goes to this side. One of these electron clouds goes to the other side. And the other electron cloud also goes to the other side, just like that. Right? So this is like two closer to each other. But they don't come very close to each other. So this is delta minus and this becomes delta plus. This becomes delta minus and this becomes delta plus. So whatever the attraction that you take place here is called van der Waals force. Right? Van der Waals interaction, van der Waals force. Van der Waals is the name of a scientist, right? Okay, question number 4. Right, let us see how the question work. Right. The first ionization energy of aluminium silicon phosphorus vary as aluminium silicon phosphorus. Aluminium is smaller than silicon. Silicon is smaller than phosphorus. Explain the reason for the above observation. Right. So aluminium, what is the electronic configuration? Electronic configuration is S2P1. Silicon is S2P2. And this is S2P3. And you can see in that direction, what will happen? What happened to the radius? What happened to the radius? Aluminium, silicon, phosphorus. These are consecutive elements in the periodic table. ළඟ What happened to the radius for these elements? Radius increases. Radius across the period. What happened to the radius across the period? Right? What happened to the radius across the period? It decreases. So radius decreases. Radius decreases. If the radius decreases, can you tell me? Okay. Also, can you tell me what happened to the effective nuclear charge across the period? Every time you add one electron, one proton, what happened to the effective nuclear charge? Effective nuclear charge, yes, exactly. Very good. Increases. So you can say effective nuclear charge increases. ZEFF increases. Now, the last electron will be more and more strongly bounded to the nucleus. Electrons are strongly bounded. Bounded to the nucleus. Then what happened to the energy? Ionization energy increases. Is it clear? Did you understand that? Any questions here? Any parts that you didn't understand? Make sure to read the note again, right? Make sure to read the note again. Right? Right, okay. Everybody okay? All right with that? Right? We are not going diagonally here. We are going across the period. Right, okay. Then question number 5. Question number 5. Try that. Try doing that. Read that. The covalent radius of the following elements PQRST is given below. Right. So this is the table that they have given. They have given this kind of a thing. Then you have this one. This is the next one. This one. And then this one. So this is how you work out. Okay, this is P. This is Q. R, S, and T. P, Q, R, S, T. This is what you have. This is the radius, not the ionization energy. This is the radius. Across the period, radius increases. Down the group, radius, across the period, radius decreases. Down the group, radius increases. Right? Okay. So this is the maximum. This gives you the minimum. Minimum to maximum. Can you tell me where do you find that? Which group, which group? Where do you find that? Minimum radius and the maximum radius, one after another. Where do you find it in the periodic table? Minimum radius, maximum radius. Maximum radius. How come the radius decreases? Your question should be complete. Very good. Group 18 and group 1. This is group 1. This is group 18. This is group 1. Maximum is in group 1. Minimum is in group 18. If this is group 1, this should be group 2. This should be group 13. If this is 18, these are consecutive elements, it's 17. That's how they are. That is how the variation takes place. Anahari. Right. Good, good. Ah, right. How come the radius decreases? I mean the fourth question. The fourth question, radius, you think aluminium, silicon, phosphorus, radius is known when you're going from across the period, from the left-hand side to the right-hand side. Radius decreases because of the increase in the effective nuclear charge. ඒවා දැන් දන්නවා. ඒවා පොඩි ප්‍රශ්න. Right? Across the period, radius decreases. Right. Yeah. Give reasons as to which group the element R belongs to. R belongs to group 1 because it shows the maximum radius in this. Right? Minimum. So Q is the minimum. And R is the maximum. Right? They are each other next to each other. So therefore, R belongs to group 1. Right, okay. R has a larger radius than Q. Explain the reason for this observation. What is the reason? Can somebody tell me? What is the reason you think that? Yeah. Then where maximum, like, somebody says minimum is Q, maximum is R. That is obvious. It is given in the table. Like, if you look at the graph, minimum is Q, maximum is R. That is not what we want. We want which group it belongs to. ඒක තමයි question එක. Right? R has a larger radius than Q. Explain the reason for this observation. Somebody send me what is the reason? What is the reason that you think? Right? So this is because of the beginning of a new period. Right? This is the old period. Group 18 means it's an old period. Old period. And this is the beginning of the new period. This is a new period. That means you are adding one extra energy level. We don't know how many energy levels are there. You can't say this has only one energy level, other one has 3 energy levels. It can be period 3 and 4. It can be period 2 and 3. It can be period 4 and 5. We don't know that. But because of the beginning of a new period, there is an extra energy level, right? Due to the presence of an extra energy level. Extra energy level. Right, okay. Explain the variation of the covalent radius of RST. What happens? Can Baran explain the variation of the covalent radius of RST? What do you think? RST, what happened to the covalent radius? What has happened to the covalent radius? It has decreased. Why? Why is it decreasing? Decreased. Explain the variation. What is the reason? Now you can tell me. Why does the radius decreases? Yeah, it decreases because of the increased effective nuclear charge. Increased effective nuclear charge. Effective nuclear charge. Increased effective nuclear charge. And the last question, it says, draw the variation of the first ionization energies of PQRST. What happened to the variation of the first ionization energies? Variation of the first ionization energies of PQRST. If you look at that, this is the first I1E. P, Q, R, S, T. PQRST, what happens to the energy? Look at this one. This is group 17, 18. So 17 is somewhere here. 18 is somewhere there. After 17, 18 should increase. Now you go for group 1, 2, 3. You know how group 1, 2, 3 varies? Group 1 has a lower value, 2 up, 3 is down. So this is the variation thing. First ionization energy varies. This is 17, this is 18. This is group 1, new period, group 1. This is group 2, this is group 30. So this will be up and down. I hope everybody understood that. Yeah. Okay. Can we write as is a defective, is a thing and effective nuclear charge? Right? Don't say is a defective. Is a defective effective nuclear charge. Yeah, 8 to 14. Due to the increase of the nuclear charge. I'm looking at your answers, right? Right. Okay. So I hope you understood that, right? So like, this is 17, 18. Now this is how the variation take place. If I put the normal energy levels, first ionization energy up, then you have down. Yeah, up, down. Then you have up and up. How many things? In one says you have 17 here. This is the 18. Then in next period, 1, 2, 3. This is 17, 18. This is this one. And 1, 2, 3. 1, 2, 3. That's all. Right? Right. Okay. Right. Now, there we will stop today, right? And the next set of questions we will do next week. Then we have made the finish that. Question number 6 and 7, 8, and the tutorial number 15 also. I'll try my best to finish that next week. Without all over, first unit is over. I can now give you an exam. First, next thing, exam and also I can do the tutorials on bonding as well. The bonding, or we can do a progress and little bit of a steady progress. After hybridization and resonance structures, I will start the chemical calculation unit also. So the chemical calculations, but until resonance structures, I won't start new things because you have to understand that well. It's very highly connected. I will start chemical calculations and we will do it little quickly. Right. Okay. So I hope you understood this. If you didn't understand it, right, and make sure to get the right answers. Complete the tutorials. Completing tutorials are very important. That is right. Okay. Hariputa. Okay. Right. Good night.